Hi folks, Chuck Black here. We are doing 52 weeks of Python and we are in week number 23, and the topic for this week is XML. That is, how do you translate to and from XML into your Python data structures and what can you do with that. So we look a little bit at the package that you may use in order to do that. There's a couple of packages. Actually, we do look at how Quokka uses XML. We took a little bit of a detour in this session and we talk about how we will call into devices using NC client and look at NETCONF XML data. And so yeah, that's what we're going to be doing. Let me tell you, full disclosure here, I'm not a huge fan of XML. I've been using it off and on for the better part of 20 years. It seems a little bit overly complicated and cumbersome to work with. I prefer using JSON and YAML. But since we are in the situation where a lot of devices return data in XML, this session is intended to begin to get your feet wet into XML and get you started in understanding how to deal with data that is structured in that way. So without further ado, let's get started. So let's get started talking about XML and how we deal with it in Python. Now, the first thing that you should notice is that this Python data that we're using for translating from Python data structures into XML and back, it's actually a different Python object than the one that we've used before. If you recall, if I click on here, we used something called inventory and we imported that. And I used that for both JSON and for YAML. But now that we are using XML, I had to change this data structure somewhat in order to make it more palatable for the XML tools that I'm using. A couple of things. One is I needed to have actually a couple of layers of dictionary so that the translation tool package that I'm using was able to not believe that I had some misuse of, multiple roots is what it was calling it. And so I had to modify that so that I now have inventory and then device in order for it to be represented in this manner that you see over there. Also, things that were integers that were fine in the other data types of YAML or JSON, I needed to do as strings because, as you can see, things are just strings in here. And I'm going to admit at the beginning that I'm not an XML expert. I use XML when I need to, but I don't use it for communication between processes like we do with JSON or storing in files like we do with YAML. So I don't use it that much, but I do have some hopefully useful things to show you. So yeah, that's kind of a little bit of the background. So just be aware of that. If I was to look at this in the code, remember we have this inventory.py file, and that's where inventory lived. And so we always were importing inventory. Well, you can see here's a heads up. When I did CSV, that data has to be different. And here's my XML data that attempts to be the same data as we have up here, but I had to represent it differently in order to have my translation package work correctly. So when we look at the XML example file, if I go to the top, you can see I'm importing XML inventory, whereas before we were just importing inventory. So let's go back. Here's how things are represented, of course, in our Python world with dictionaries and lists. And this is what things look like in XML. I'm not going to go into a deep discussion of all of the aspects of XML. It's been around for a long time. It's fairly verbose. It is robust in the sense that you can define all kinds of different stuff and ways of defining these different tags, and there's a whole lot of extensibility to it. It'll look similar to HTML, which is actually derived from XML. So just so you know that and you understand these angle brackets, but you can probably get an idea. It's fairly human readable. I'm looking at my inventory. Here's one device. Here's another device. This is the beginning of the device. This is the end of the device. If you're familiar with HTTP, you know how that works. Here's the name, and then inside this, the beginning and ending name tags, I have the actual data. SSH info, if I have another tag within a tag, as I've had inventory and device, but here SSH info. Here I have host name, and then there's the actual value that I had to abbreviate to fit it on the slide, in the end host name, etc. You can see that they're roughly analogous to a dictionary. There's my host name, and there's the actual name of the host. You can see that the outer level here that looks like it might be something like a dictionary. Yes, it is a dictionary. In this situation, I have multiple of these device tags, and so that's going to be analogous to what we have and we call a list in Python. Things are a little bit less defined in XML, and my apologies if any of you are XML experts. As I mentioned, I use it when I have to, and my intention is not to give you tons of detail about XML and all the wonderfulness of it, of which I'm sure there are many things, but we're just going to look at how we might use it and why we might use it. So let's look briefly at this. I'm not going to go into the terminology because it's a little bit of a slippery slope. We have lists and dictionaries over here. You can see that over here we have tags and then data, and the data can be another tag, and then you eventually get down to a portion where there actually is real live data, similar to what you have with dictionaries. And if you have multiple of these, then they become like a list in Python. Now I am using this tool right here that I downloaded. So this is something, when you do this lesson, you are going to have to do a pip3 install of xmltodict. There are very many XML packages that are available out there. Ltree, etree, lxml. We'll look at those a little bit as we go through this lesson. The one that I used that I found the most useful, because I wanted to learn a minimum of parsing XML and a maximum of utilizing what I know from my Python abilities, then I used xmltodict in order to get this XML into a dictionary and list type format so that I could deal with it with the skills that I have, which are Python skills. And I didn't want to go down and learn XML. Now, just taking a little side note or a tangent here, this is going to be something that you'll find yourself doing quite often. For example, I didn't want to learn how to write my own web server and RESTful API capability, and so I'm importing Flask in Quokka, and I'm using that. I don't need to learn all the different nitty-gritty details of how to build a web service. I'm utilizing Flask to do that. And what you will find in software is if somebody has already built a library or a package to do things for you, and it's not fundamental to your job description that you become an expert in XML, then by all means, in my opinion, go ahead and utilize the skills that you have. So we would call this your core competency, or whatever terminology you want to use. You're an expert at doing Python stuff, so stick to the Python stuff and let other packages do the nitty-gritty of whatever that might be. Now there's tools that will allow us to parse this individually or to find things, and we'll look at that, but I'm using xmltodict, and I think that it's a wise way to do things, and that is to get it out of this structure, language, data description format into something that you know and understand, which would be Python, hopefully at this point. So the package I'm using is xmltodict, and I will use parse to take it from XML string into Python, and then unparse, not very creatively named, but I guess it makes sense. Unparse is to take it from Python into XML, and that's the same as what we had before. We called it load and dump, and that's the similar type of functionality. Now the last thing that we're going to look at is here in these slides is, do I use XML in Quokka? The answer is I don't use it by choice, for any of the data transfer mechanisms and functionality that I needed to implement. I pass in, rather than XML, I've chosen JSON to pass in and receive data back and forth. So I'm using JSON for that. For my configuration files like we looked at before, I'm storing those in YAML. But if you're going to do NETCONF, NETCONF has chosen to use XML for defining the data that gets passed back and forth with certain devices. So in Quokka, I have implemented a little taste of doing NETCONF, and in order to do that, I have to receive and then parse XML information. And at the end of this lesson, we will look at how I do that. And in fact, I've learned a little bit more of what I might be able to do for getting the CPU utilization and memory utilization, thanks to a friend and viewer of these videos who passed me along that information. So I may be implementing that in the future, but for right now, I've done just a little bit of the XML received from the devices that I am monitoring. Okay, so that's kind of the overview of what we are doing in this lesson with XML. Let's get started looking at the code. All right, let's look at the example code that we have for learning XML. You'll notice that it is in the sequence here. We did JSON, we did YAML, and now we're doing XML. And one thing that I want you to notice from this file, let me get rid of this because we don't need that, and I'll make this a little bit bigger. One of the things that I want you to notice is fundamentally, I'm doing exactly the same things that I did in the JSON and YAML. I am going to reference this data, which is the XML inventory. That's what we found and that I alluded to here. This is my XML inventory data. I had to do something a little bit different than the normal inventory in order to make it consumable by XML. So that is what we are going to be using. And what I do first is I open a file for output. That's the .xml one that we haven't looked at yet, but we will. And I write that out. And what I'm writing out is I'm taking this XML inventory, that's the thing, the Python data, and I'm calling into this package xmltodict, and I'm calling the function unparse. And basically what that does, remember our picture from before, let's see if I have it handy so that we can look at it. Unparse, whoopsie, I'm looking at the wrong thing. Let's go down here. Unparse, when we go from Python to XML, we call unparse, and we parse it when we go from XML to Python. So that's what we are going to do. We're going to take this thing, which is Python data. We're going to write it out into a string. I specify pretty equals true. That means it's going to format it nicely, and we write it out to the file. Now, what does that look like? We're writing it to this file right here, the one that we just opened, L00inventory.xml. That's this one. And as you can see, sure enough, it prints it out, and it does actually look pretty nice, and it's in a readable format. And you'll notice if you go back and look that it reflects what we have in this slide. Hopefully it's exactly the same, but I might have changed something. Anyway, it's fundamentally the same thing. So that's what happens. We write it out to this file. Now this file has that XML data written out to it. What we do next is we're going to read from that very file, and we are going to remember when it goes from XML string into Python data, we're going to do a parse. So I'm going to read that data in. This read here, just like before, it ends up giving us a very big string full of this XML formatted data, and we parse it and we save it into these Python data structures. One thing that I didn't mention, I'll just make sure I go through. Remember with JSON doesn't care about white space or indentation. You can do whatever you want. YAML does care about white space, and now that we're back in XML, XML does not care about white space. So you can make this all in one single line if you wanted to. It's able to recognize these tags. So We've now read it back into the saved inventory. I call it saved inventory just like before because it's what I saved and then I read it back in. Now what I'm going to do is I'm going to use pretty print, which I didn't do in the other examples, and I'm going to pretty print this Python data structure. And I'm going to pause right here because I want us to look at the output of this. So I'm going to go up to the front here, and this is where it says XML pretty print pprint version, and then I specified Orderdicts. Why did I say Orderdicts? Well, guess what? Pretty print, when I print out this saved inventory, if it is saved instead of using a normal Python dictionary, it uses something called an Orderdict. And if I was to ask you, what do you suppose Orderdict does that's different from just a dictionary? Well, especially if you're familiar with using Python and dictionaries, but maybe you picked up on this if I've mentioned it before, a dictionary stores items with key value pairs. Each item is a key value pair, and it doesn't store it in any particular order. In other words, if I add items 1, 2, 3, 4, and 5, and if I was then to try to iterate the dictionary and print them out, it would print it out in whatever order it chose to store it in. You can choose to have this thing that is relatively new. I can't remember when they added it, but it's an ordered dictionary. And what ends up happening with an ordered dictionary is it will preserve the order in which you added the items so that when you iterate through them, it comes back in the same order. That's all well and good, but guess what? Pretty print, our nice little formatting of output of a Python data structure, does not behave well with ordered dictionaries. Now, if you wanted to walk through this, you could do this when you write this code yourself, and you can see, oh wow, it's an Orderdict, and this is a parentheses. The data in the Orderdict is going to be, first it's going to be a list, and then it is going to be a tuple. And the tuple is going to have two items. The first item is going to be this string. The second item is another Orderdict. Now, you're probably, if you're an old hand at this, then you may have seen this before, because sometimes packages that you use, like I believe SQLite does this when you read things from a database, it will actually, instead of creating a dictionary, it will create a tuple that has two entries. And the first entry is the key, and the second entry is the value. And so what you're seeing here is pretty print's attempt to print this out. Now, if you were to spend a lot of time looking at this, you could probably figure it out. Okay, well, here's my name, here's my SSH info, which includes a host name and a port and a credentials. But man, try to parse this in your brain as a human. That's very difficult. So what can we do? Well, the good news is with this parse functionality, you can tell it that you don't want to use the default parsing, which uses Orderdict, but our parsing, we want you to use just a regular old Python dictionary. And so this next piece of code, if you were to look at this code and compare it with this code, it's exactly the same. The only difference is I've added this extra parameter that says my dictionary constructor, I want you to use dict instead of Orderdict. And I'm going to scroll down here on the output. Let's see what the output looks like. And I can hear you breathing a sigh of relief. You're looking at this and you're going, I don't want to have to deal with that. Actually, dealing with it in Python code is very easy to do. You can treat it just like a regular dictionary, and it behaves like a regular dictionary. The evil culprit here is pretty print. It's printing it out like that. But our when we use dict constructor equals dict, then that allows pretty print to print it out in a way that we like. So this is really easier for us to read and understand. And this is my Python data structure. Now, in my Python data structure that we read in, Notice there's a bunch of extra baggage here. The reason for that is that this function that we're using, XML_to_dictionary, for some reason in my experience, it is uncomfortable with Python data structures that don't start with two. Number one, that doesn't start with the dictionary, and number two, that doesn't start, actually, I found, with two dictionaries in this way. So in order for me to do this list, I have to have it be a dictionary followed by a list, or it complains about having multiple roots. And you may be more familiar with this if you've done it before, but this is just how I had to do it. So this is how I've structured the code. You can see it's the same code as what we have up here with our simpler version, but I had to do this in order to get it to play nice with XML. And going back to our example here, when I print it out, when I have used the dictionary instead of ordered dictionary, it is like what we would expect. This is a dictionary, the key is inventory, the item is another dictionary, the key is device, and the data here is going to be this. I'll stop it right there, that list. And there's actually going to be a couple of devices. What does that look like? I'll give you a little clue, a little heads up. This is what it's going to end up looking like in XML. Inventory, device, begin device, end device, begin device, and I've shown you this in the slideshow that we just did, end device. And that is what ends up happening here. I say XML pretty version, XML pretty version. This is overloading the word pretty, but I use the word pretty version because there's actually, when I do an unparse, I can specify pretty equals true, and it will do it like this. And so that is what it ends up looking like, and that, sure enough, that's what it looks like in our file. This actually looks a little bit nicer because it color codes at least the XML tags and versus the data. Now, we've gotten past that. We have this data. This is what it looks like in a pretty format. Now the important thing, the rub of this whole thing, is to figure out, is the thing that I just read in equal to the one that I used at the beginning? Remember XML inventory? That's the thing in my Python file. That's this thing right here. And the question is what I wrote out and read back in, that's what I called the saved inventory because I saved it and then I read it in again, are these two equal? And as a matter of fact, the two are equal. And just as a side note, if I were to get rid of my dictionary constructor and allow this to be created with ordered dictionaries, the equivalency operation is smart enough to know that a dictionary is, when it does this comparison, it is able to compare them equally. In fact, why don't I just do that? Let's see. This is where I changed the saved inventory to have the dictionary constructor. So I'm going to do this, and I'm going to comment that out. I hit my control, my left control, and the forward stroke key, or slash as we call it here in the US. Let's see if I did that correctly. All right, so here all we have is the Orderdicts. That's all that we're looking at. So my saved inventory is actually this ordered dictionary. I printed out the pretty version, and then here's my comparison. And sure enough, even though one of them was an ordered dictionary and one was a regular dictionary, the nice thing is that the two comparisons can work appropriately. So that's this file. Hopefully you have a general idea now. This is the same general idea as what I did with JSON and what I did with YAML. Simple file, reading in Python data, writing it out, reading it back in again, converting it, and sure enough, it's the same. So what I'm going to do now is we are going to actually peek ahead to stuff that I have done. This is kind of my sandbox for playing around with different types of stuff as I go forward. I haven't completed all of this yet. Some of these I probably won't do, but you can see I've got napalm in here. I've got connect module which has connect function in it, and down here you can see I have a NETCONF example. Remember from our slide when we looked at when we asked the question, does Quokka use XML? The answer is yes, it does when it needs to get to NetConf data. Now you should know this. If I'm using napalm and I'm communicating to a device like a Nexus device or a Juniper device, and those devices communicate using NetConf, I don't even have to worry about that because napalm takes care of all of that XML-iness for me. It shields me from having to know the difference between parsing SSH output from a device's CLI versus using NetConf, or I suspect it could be true that it could shield me if I had to use SNMP. I don't know if napalm has implemented any of that, but you get the general idea that that's what napalm does for me. If I'm using a more raw version, as I'm doing in this NetConf example, then I'm going to be dealing with XML data. That's what I end up doing in Quokka, and that is what this particular file is attempting to do. Now this file has a lot of stuff in it, and I am not going to go through all of this because we're not doing this entire NetConf example, but I do want to show you a little bit about how this would end up working. Now my file here, I end up only talking, I think, to one of these devices because the other ones were misbehaving. I have a for loop, but I'm only going to the one device as it stands currently. I'm using, as we can see up here, I'm using NC client. Again, I'm not going to go into NC client here, but I establish a connection with an actual device. This is the device that I was talking about here. This is the sandbox device. What I'm going to do is, if it's a Nexus device, I have to use different XML stuff depending on the device type. This is an unfortunate reality when dealing with Cisco devices, is all the different product families have their own XML definitions for how you get at various information. And so the stuff for Nexus is going to be different for the stuff for other devices, etc. And let's see, I can't remember how I left this. So, but just so that you know, you have to do things differently if you're using Nexus devices versus other devices. With napalm, you get to tell it at the beginning, I'm talking to a Nexus device or I'm talking to an iOS device, and it figures everything out for you. But here, that is not true. So I have to give a bunch of this gobbledygook, which we're not going to go over. But what I will do is I'm going to run this, and we're going to take a look at some of the output, and then I want to make a point for you so that you will remember this. Let me get rid of this. It takes a while because, of course, we're talking to a real live device. You can see I got some information back. This is actually the configuration of the device. You can see it gets kind of ugly and nasty. And if I was to, you can see from my scroll bar, there's a lot of stuff here. One thing that I did was I got all of the configuration. You can see that this is a little bit messy. From a standpoint of parsing it, etc., it's better than using SSH in the CLI because you don't have to parse, the output of the way that they decided to write it out in a table or whatever and do screen scraping. So this is better from that perspective, but it is very verbose, and you can see why people at one point in time said, you know what, this XML stuff is a little bit for the birds. What if we did things different? And so people have used other mechanisms. So I'm going to scroll down here to something towards the bottom, and I'm going to work my way up from the bottom because I just wrote some of this today. One of my buddies who's going through the class gratefully gave me the actual NetConf filter that I can use to get CPU usage and to get memory statistics, memory usage for the device that I'm looking at, a Cisco iOS device. And so what I did is I went through and I got that information. Now here is, I'm going to show this to you. This is the CPU data. The CPU data does not tell me one CPU utilization number as I wish it would. It basically gives me a dump of the process table. So here you can see process ID number 1, process ID number 2. Guess how many processes are actually running on that thing? Well, this is 624, and my cursory examination leads me to believe that there are actually 624 of these things, and I haven't figured out what all of this means in terms of how I might calculate the CPU utilization. But anyway, that's it. The memory stuff is a little bit nicer. This is the XML memory stuff right here. So I can see that the data that I got back, memory statistics. Here's the first memory statistics. It's from the processor. This is the total memory. This is how much was used and how much was free. And this is for the LSMPI_IO, and that has its own value. And I can imagine I can probably, mathematically take this and figure out what the memory utilization is for the processor or whatever. But looking at this, you might say to yourself, well, that's great. How do I deal with that? And let me show you a couple of things up here a little bit closer. When we go and we get data from devices, you can do things with this XML. This is the configuration. This is the big configuration file that we saw at the beginning. You can say something like get elements by tag name. And again, I don't want to go through all of this for you. This is in different libraries that we are using. There's this LXML library which we can use in order to go through the actual data that we want to get back. Now I need to find out where I was, which was right about here. I can say get elements by tag name, and that will find in all of that mess the username, and from here I can actually end up getting the value for it. And in my situation, you can tell this is kind of kludgy. I'm getting name, the first name. I have to go first child because these all of this is like in a tree, and you can see that this is the parent of this and that that's the parent of this, and so you kind of need to understand this. And here's the reason that I want to tell you this. I actually extract somewhere up here, I extract information that tells me, let's see if I can get down here. So here you can see I extract the version for this particular device, and I also get the host name. I'm not able to get the email. I get the name, and these are all the different names that exist for the device. So I was able to get all of these from that device by using this get elements by tag name. Here's my usernames. That's where I printed that out. So you can do something like that. But here's my point that I want to make. Do you really want to learn how you parse and walk an XML document with all of this nesting, etc., and learn all these new functions? And my answer would be, if this is your job to deal with XML and this is how you need to do it, then by all means learn this stuff. If you're more like me, then you might say to yourself, I've just gotten back this information from my, from my either my CPU subtree or my memory subtree. And what about if I took the output, that would be this etree.toString response.data element. What if I was to take that and I was to push it through my XML to dictionary and to do a parse? Remember parse? Parse is going to take the data from this. That's this YAML. Again, I'm doing this incorrectly. Let's go to the right one. Take it from this XML and change it into Python. Guess what? I know how to deal with dictionaries. I know how to deal with lists. I know how to deal with keys. I know how to deal with strings. And numbers, and all of this other stuff. I can do that. This, how do I walk through this? That is confusing to me, and I don't know how to do that. So my suggestion to myself was, why don't I just read this into Python, and then I can deal with it in Python. And that's exactly what I am showing you right here. I'm doing xmltodict of the stuff that I got back. Whoops, let me go down to the bottom. This memory thing, this data right here, which I wouldn't know how to parse without teaching myself how to do get tags and to walk through this tree. However, guess what? I do know how to walk through a dictionary and how to look at my data here and to say, okay, well, this is this here, this is this one. I could go and say, get me memory statistics. And then my memory statistics would go through and I would have memory statistic. Let me go and show this to you, make it a little bit bigger so you can see. I could walk through here, and now I could dereference the 0th item, or I could find the one with the name processor, and then I could go and grab the total memory and the used memory. And from that, I could figure out, okay, well, I'm using this much of my memory. I know how to do that in Python. It's, in my opinion, way easier than having to learn a lot of the details of going through things and learning all of the different methods that I would have to use for traversing this XML document. This one is easy. So if there's just like one version, then that's an easy thing for me to do. I couldn't do the same thing for memory statistic because there's multiple of them, or maybe I'd have to go through them and figure them out. Anyway, you get the general idea of what we're able to do because of the fact that we have this XML to dictionary, and we can now deal with it as a Python data. But it would be up to you if you wanted to go further with your XML experience, because you're going to have to do that for your job or deal with it in a great detail. Then by all means learn all about etree and lxml and all the other packages. If not, then you can take the data and parse it and then deal with it as Python data. All right, so let's look at how Quokka uses XML. And I'm going to tell you right up front, my usage of XML, as we talked about, is just because I wanted to demonstrate getting device status and information using NETCONF. So I get to use NC client and show how we could do that. But my implementation, I'm sure, leaves a lot to be desired. And given the information that you saw about getting the CPU and memory utilization, I have not implemented that yet. All I am able to do, well, you'll see what I'm able to do. So device monitor task, this is when I'm going out to devices in Quokka. You can see I'm in Quokka here. So even if you don't understand Quokka, you can bear with me when we go through this. Get device status, this is when I'm going to go and figure out what the status is for the device. The things I'm going to be looking to get are going to be availability, response time, CPU, memory, and last heard information. Now, availability and response time, that is stuff that I just get because I know, did I talk to it or not, and how long did it take to get that back. Last heard, I know, I just a timestamp. CPU and memory, that's stuff that I need to glean out of the device's XML, and there's also some other stuff that I do as well. So here I come through and I say get device status, and if we scroll down here far enough, device status, we're going to end up, so here in device status, if we scroll down a little bit, we're going to see, okay, if the OS is iOS, iOS XE, and the transport is Napalm, that's a little bit easier. If it's not Napalm, then instead of being able to call the nice Napalm thing, I'm going to have to do something that's more manual, and that's calling get device info. And so I'm going to call get device info, and this is going to look at the device transport again. If it's Napalm, it's going to do one thing. So there are things that I do elsewhere that require device information, so I get to be calling Napalm for that. But here I'm going to actually be calling NETCONF, and so I'm saying get device info NC client. If I go down into that, you can see that what I'm going to attempt to do is connect to the device. So this is my NC client connect functionality. From here, well, let me show you here, manager. If I go up to the import, then you can see NC client manager. That's where that came from. Here is my NC client. I'm going to connect to the device. I'm going to get the configuration from the device, and then based on that configuration, I will now have, if I was only going to get the config, then I'm done with that. If I've requested to get facts, then I'm going to set the vendor, the OS version, host name, FQDN, and serial number I don't have yet, so I'm going to attempt to get those. So I am using some of this XML library, this xml.dom.minidom. Again, what I might have wanted to do, and I might change this in the near future, would be to translate it into Python, and then it would make it a little bit easier for me. But basically, I'm using this functionality that we talked about called get element by tag name. So I'm getting the version, and then I'm getting the host name. And then I'm going to go, again, I have to do this ugliness of dereferencing the first version that I got and hope that that's the important one, a dot first child, so there must hopefully be one child, and then get the value of the data associated with that. If this looks like gobbledygook to you, it is an unfortunate virtue of using XML and the way that it all is set up. This is making me think it would have been much nicer if I'd just used Python. I may go back and rewrite this, so you're actually helping me out here. The next thing that I do is I go and I try to get the serial number for the device, and if I'm able to get that, then let's see, do I actually write that? I'm not sure I actually do anything with it. Maybe I was going to do something with the serial number and I ended up not doing it. But you get the general idea here. This is what I'm doing. I'm setting my facts to the basics, and then I go through and I end up setting the OS version, the host name, and the FQDN based on XML data. Like I said, it's just like barely on the on-ramp of doing a true XML management of the device, but because I didn't really want to go into all the detail of that, I've used other tools. Juniper has PyEasy. Cisco has other Python libraries which shield you from having to do XML. So this is more, I'm assuming, something that will be, unless you have to deal with this on a day-to-day basis, it's going to be something that will be good to lock away in the vault of your mind, and maybe you don't have to use it in the real world. But having some understanding of the different packages that are available and how you would use them, hopefully this will give you a little bit of that background information. Okay, so let's review what we're talking about in this lesson. Of course, we're talking about XML and how data is represented in the XML format. We talked about how you can use xmltodict in order to parse, which would be to go from XML into Python variables and objects, and how to unparse, which is to get it back into XML format. We looked a little bit at how XML is used in Quokka. It's not really used for much of anything except by virtue of the fact that devices sometimes return XML data formatted in the XML manner, and that is certainly what NETCONF does. And so we looked at some applications. The first application was similar to what we've done before, where we take the data from the inventory. We mentioned that our inventory is different. We have to have separate XML inventory in order to have it be in a format that is enjoyable for our library, which is xmltodict. As usual, we took the Python data, we wrote it out, and then we read it back in. And after reading it back in, we parsed it into Python, and then we compared it with the original and made sure that it was okay, just like we did before. One small thing that we did do was we noticed that when we try to do a pretty print of ordered dictionaries that comes out looking funny, so we use this parameter to pass into the xmltodict.parse function, and that causes it to use regular dictionaries rather than using ordered dictionaries. Now, we looked at this NETCONF example, which is from module number 4, so it's way ahead of where we are, but we basically talked to a real device, got some XML data back. We looked at different libraries. We used XML and etree in order to go through some of the data. We also used this xml.dom.minidom in order to parse the data. Now, I didn't go into any great detail about these because I'm of the opinion that you should put into your brain just the things that you need, and I advocated converting the data into regular Python format and going through it in that manner rather than attempting to traverse the XML structure using other tools. I'd prefer not to have to learn another tool. So we looked at how we did that. We looked at CPU and memory utilization, and we actually were able to print stuff out and make some type of sense from it. We also dove into a little bit of Quokka. Now, Quokka doesn't do XML except under duress. I like to say basically when we need to do NC client directly to the device. In other words, napalm will do all of the translation into Python for us, but if we have to do raw netconf out to a device, then we need to do some XML. So we looked at how we do that, and I mentioned that I may be adding the memory and CPU utilization to that. And so that's basically what we went over. Hopefully some of that at least made sense. If you're new, you may not ever have to deal with this. If your life does involve dealing with netconf and XML, then you'll want to, if you're just learning it, you'll want to take what I explained as sort of a springboard into going a little bit deeper, maybe to understand XML a little bit better. But hopefully this has been helpful, and that you now have a better understanding of the whys and wherefores of XML, what it is, how to use it, how to make it easier to use by using something like xmltodict. Hope that helps. Thanks.